Hi everyone, I'm Sepidana Shaswar, a PhD candidate in computer science at the University of Maine. My research mainly focuses on improving the efficiency and robustness of deep learning and graph neural network models. I have experience in teaching in workshops and boot camps, and I enjoy making complex topics intuitive for the students. Today we are going to talk about autograph, its importance, and a simple practice on that. Autograph is a differentiation engine of PyTorch which finds the derivatives in an efficient way for backpropagation. It's crucial for training in deep learning models, and without autograph, we have to find these derivatives manually, which is inefficient and error-prone, especially for complex neural networks. Autograph provides dynamic computational graph, meaning that the computational operations are recorded as directed graphs, where the nodes are the operations and the edges are their dependence. Now let's jump to the practice. In this practice, you are supposed to implement a single neuron with scalar input and output, which are with some learnable parameters W and B. Using this figure, you have to fill out the blanks over here, which is finding the prediction, and over here, which is finding the loss. Before jumping into the implementation and writing the code, it is notable to mention that over here, the learnable parameters W and the B, which are the weights and the bias, are defined in a way that is differentiable, which means that the system keeps track of these variables and their operations. This is done using this parameter requires underscore grad, which is passed as true. Now let's see how the prediction should be calculated. So the input should be multiplied by the weights W and added up to the bias B. And then the hyperbolic tangents should be applied on that to have the prediction. So to write the code for this simple operation, we have the input is multiplied by the weight of this class object plus the bias of this class object. And lastly, we apply the hyperbolic tangent, which is a built-in function in PyTorch. Now, after finding also, we have to comment out this line to avoid the errors it throws. And then to find the loss, what we have to do is that we have to difference between the true variable y and the predicted variable or value. So we say y underline true minus y underline prediction, and then if to the power of 2 is equal to the loss. And comment out this line, and then we run this code. As you can see, this is the result. And it's worthwhile to mention that before that, we have to import Torch because they are using this library. And the result shows that the loss is equal to 49, with the input is equal to 1.